So let us do the analysis of energies of a satellite that is moving around the Earth in a circular orbit. So there are two kinds of energies that the satellite is going to have. The kinetic energy is going to be equal to half mv square. So this is the orbital velocity v. We know that the orbital velocity is given as under root gm upon r. So this is going to be under root m gm upon r. Okay, so this is going to be equal to half g mm upon r. The potential energy is minus g capital M small m upon r. Capital M represents the mass of the earth and small m represents the mass of the satellite. So this is the potential energy. The total energy is going to be the addition of potential and kinetic energy. So if we do that, we get gmm upon r. We can take common outside the parentheses. We will get minus 1 plus half, and minus 1 plus half will give us minus half. So this is equal to minus gmm upon 2r. So this is the total energy of a satellite. Now this total energy, we can see that this energy is negative. The meaning of negative energy is that the satellite is moving around the earth in a bound orbit. So this orbit is bound, meaning the satellite is bound to the earth with this particular magnitude of energy. The reason for this being negative is because potential energy is negative. Why is potential energy negative? Because at infinity we have assumed the potential energy to be zero, and as we move from infinity towards the earth, the gravitational force of the earth does positive work, and whenever a conservative force, which gravity happens to be, whenever a conservative force does positive work, potential energy decreases. So here the potential energy is going to be negative, and thence the total energy is minus gmm upon 2r, which happens to be negative. Now what happens if we supply the magnitude of total energy to the satellite? So the magnitude of total energy is gmm upon 2r. This is the magnitude of total energy. So this is called as the binding energy, which is essentially the magnitude of total energy. What happens if we supply this particular amount of energy to the satellite? Then we can understand that the satellite will have a net zero energy. So this binding energy, if this is supplied to the satellite combined with the initial total energy of the satellite, so net these two energies will cancel each other out and net will have a zero energy. So what does that mean? When does a satellite have zero energy? We have seen that a satellite has zero energy when it escapes to infinity. At infinity, when it just escapes to infinity, we have seen while calculating the escape velocity that energy at infinity happens to be zero. So a satellite is going to have zero energy when it reaches infinity. That is the short summary. Because at infinity, if it has zero energy, that means it has zero kinetic energy as well as zero potential energy. So at infinity, it is going to have essentially zero energy. So here, this quantity gmm upon 2r, this is called as the binding energy of the satellite. So this is the binding energy. It can be interpreted like follows. It is the total energy, total positive energy that needs to be given to a satellite in orbit in order to make the satellite escape to infinity. This is the first interpretation. And binding energy is the energy with which the satellite is bound to the earth as it is revolving around the earth. This is the second interpretation of binding energy.